All right, everyone, get ready, because today we're going deep into Expert AGI. AI that can perform like the absolute best in any field you can imagine. Think like the best surgeons, master engineers, even world-renowned composers. We're going to break down this super interesting new research paper. It introduces this benchmark called MMMU, and it tries to answer a really cool question. What would it take to actually build an AI that could pass college-level exams in tons of different subjects?
What's really cool about this research is that it tries to actually define expert AGI. There's this proposed taxonomy by Morris et al. It says expert AGI means an AI that's always performing at the 90th percentile of skilled adults. That basically means acing those standardized tests across a whole bunch of different skills.
Okay, so wait, we're talking about AI that could actually beat most of us on the SATs, or even like the MCAT. Makes those late night study sessions feel a little bit more scary.
Exactly. And it's not even just about passing these tests. This level of AI performance could change so many fields. Morris and his team point out that we have to think about the bigger picture, like how this could affect jobs in the future.
Yeah, definitely not some sci-fi thing anymore.
Yeah.
Makes me wonder, what does this benchmark actually look like? Is this AI writing essays about Shakespeare or something?
Not exactly literary analysis, not yet at least. The MMMU benchmark uses a pretty clever approach, actually. It uses real college-level exam questions and materials. It's a mix of multiple-choice problem solving and even analyzing images. So it's not just about understanding words, it's also about understanding visuals, like diagrams and charts.
Wait, images too. So it's testing if an AI can understand a graph or even a medical scan. That adds a whole other level of complexity. I'm starting to get why this is such a big deal.
Absolutely. MMMU is all about testing something called multimodal understanding. It includes 30 different image types, from sheet music to medical scans to blueprints.
Whoa, sheet music. So this AI needs to know about rhythm and harmony. I'm picturing an AI conducting an orchestra now. How many subjects does it actually cover?
It covers a lot. We're talking 30 different subjects and 183 subfields.
Okay, I have to ask, can we actually see some examples of the questions this AI has to answer?
Sure, let's take a look. Imagine in art and design. The AI needs to spot a wrong musical interval on sheet music. So it needs to understand what it's seeing and music theory. Then in business, it might have to figure out probabilities from a graph of a poll. So it needs statistical knowledge and to understand the visual data.
So it's not just knowing stuff from textbooks. This AI needs to use that knowledge with visuals in specific fields. That's totally different. What other challenges does this benchmark have?
Let's look at health and medicine. Here, it might have to figure out what's causing something it sees on a breast MRI scan. We're talking about AI potentially looking at medical images and giving diagnoses.
Absolutely. Diagnosing from a scan. That's crazy.
And this is where it gets even more interesting. The MMMU team tested some of the top AIs out there, like GPT-4V and Gemini Ultra, to see how they do against these challenges.
Okay, I'm hooked. Did these super AIs pass with flying colors?
Not really. The results were actually pretty surprising, even to the researchers. GPT-4V got a 56% accuracy score, and Gemini Ultra got 59%. Pretty impressive in a lot of ways, but that's definitely not human level.
Hold on. Even GPT-4V is basically failing. It's okay. That's kind of comforting to hear. But where did these AIs struggle the most? What were their biggest weaknesses?
That's where looking at the errors gets really interesting. It kind of tells us about the problems we still have with building really good expert AGI. The biggest problem was what they called perceptual errors. It was a lot of the mistakes, like 35%. Basically, the AIs had trouble understanding what they were seeing, especially when it was about a specific field.
So even though they could technically see the image, they didn't actually understand what it meant in the context of a medical scan or a diagram of some electrical thing.
Exactly. And it shows just how hard it is to go from just basic visual recognition to really getting the meaning of that visual information in a specialized field. For example, they gave an example in the paper where an AI correctly labeled all the parts of a circuit diagram, but then it couldn't actually solve the problem, even though it needed basic electrical engineering principles. It's like recognizing all the letters of the alphabet, but not being able to read or write.
It's like they don't have that deeper understanding that comes with experience and special knowledge. What were some of the other things that tripped these AIs up?
Well, about 29% of the errors were from what they called lack of knowledge, which basically means the AIs didn't know enough about specific fields to understand the hard concepts behind the questions. They might be good at picking up on patterns, but when it came to deep specialized knowledge, they weren't good enough.
It seems like it's one thing to be able to identify something, and another thing to actually understand what it means. But what about reasoning skills? Were the AIs able to kind of put two and two together?
That's another area where they struggled. Reasoning errors made up about 26% of the mistakes. This means even when they had the information and the knowledge, sometimes they couldn't use logic or math to get the right answer. It's like understanding grammar, but not being able to write a sentence that makes sense.
So it seems like we're still pretty far away from AI taking over colleges, which I have to say is a bit of a relief.
Yeah.
But it does make you think, what does this tell us about the future of AI if even the smartest AIs are struggling with this stuff? Where do we even go from here?
That's the big question. And this research shows us some important areas for future research. For example, that whole problem with perceptual errors suggests that we need to teach AI to not just see things, but to understand visual information depending on what it's about. It's not enough to just recognize a pattern. AI needs to get what that pattern means in a specific field.
So it's about bridging that gap between just seeing something and actually understanding it, going beyond just recognizing an image, to actually understanding what it represents in a specific field.
Exactly. And when it comes to the lack of knowledge problem, we need to find better ways to teach AI deep specialized knowledge. It's not just about giving it more data. We need to figure out how to present knowledge in a way that AI can really understand and use, maybe by copying the way humans learn and understand information.
That's super interesting. It's like we're not just teaching AI what to think, but how to think.
Exactly. And this is where things get really exciting. One promising thing is something called knowledge graphs. They're basically maps of concepts and relationships that can help AI understand how different pieces of information connect. Think of it like a huge web of knowledge, where each dot represents a concept, and the lines between those dots show how they're related.
So instead of just memorizing random facts, AI could start to see the bigger picture, like how different ideas relate to each other, and how to use that knowledge in different situations. That sounds like a huge step forward. What about the reasoning part? Any promising stuff there?
One exciting area is something called neurosymbolic AI. It mixes the power of deep learning, which is great at recognizing patterns, with symbolic reasoning, which is how humans work with abstract concepts and logical rules. It's like teaching AI to think both intuitively and logically at the same time.
So we're talking about a hybrid approach, combining the strengths of different AI techniques to create something even better.
Exactly. And it's this kind of teamwork between different fields that's likely to lead to the biggest breakthroughs in AI.
It's like putting together a dream team of AI researchers from different areas, each bringing their own special skills to the table.
Exactly. And while we're talking about teams, it's important to remember that creating Expert AGI isn't just about the tech itself, it's also about the people building it and using it. We need to make sure AI is being developed ethically and responsibly, with a focus on human values and how it affects society.
That's really important. We can't just focus on what AI can do without thinking about how it might impact society.
Absolutely. It's a challenge with many sides. That needs researchers, policymakers, ethicists, and the public to work together.
It's like we're all in this together, trying to figure out how to navigate this new world with AI.
Speaking of navigating, the paper also talks about some of the specific perceptual errors that GPT-4V made, and it's super interesting stuff. They divide these errors into basic and domain-specific. Can you tell us a bit more about that?
Sure. Basic perceptual errors are the ones that seem super simple for humans, like messing up the order of images that are described as from left to right, top to bottom. You'd think an AI could handle that no problem, right? But it's actually harder than it seems.
I can't imagine making that mistake. But it shows that us humans just naturally understand spatial relationships and visual cues that AI might not get yet.
Exactly. And then you have the domain-specific errors, which are even more interesting. These usually come from not knowing enough about a particular field.
So even though the AI can technically see the image, it can't interpret it right because it's missing that crucial domain-specific knowledge. Exactly. A good example from the paper is about computer science. The AI was shown a diagram of something called a deterministic finite automata. To put it simply, it's like a flowchart. It uses circles and arrows to show all the possible steps a computer program can take. The AI could identify the basic parts, like the circles and arrows, but it didn't understand what they specifically meant in computer science, like recognizing that a double circle represents a specific state in the program.
That makes sense. It's like looking at a medical scan. You and I might just see shapes and shadows, but a doctor can see tumors and fractures and all sorts of things because they have that specialized knowledge.
Exactly. And it really shows the difference between simply processing what you see and actually understanding it on a deeper level. The paper even says that GPT-4V often showed a bias towards text, sometimes focusing more on text than visuals when answering a question, almost like it was relying too much on its language abilities and not trusting what it saw enough.
It's like it's trying to read the instructions instead of just looking at the picture, even when the picture would be more helpful. So even with something as simple as a diagram or chart, context is really important. And understanding that context often needs more than just recognizing the parts. It's about knowing how those parts relate to each other and what they mean in a specific field.
Right, and that brings us back to integrating different kinds of information. Even our most advanced AIs are still learning how to balance and combine information from different sources like text and images.
It's like they're still learning how to use all their senses effectively, just like a child learning to navigate the world. This whole discussion about lack of knowledge and reasoning errors makes me wonder, how do you even start teaching an AI all that specialized knowledge? It can't be as easy as just uploading textbooks, right?
You're right, it's way more complicated than that. One of the biggest challenges in developing AI is figuring out how to present and teach knowledge in a way that AI can actually understand and use.
So it's not just about the data itself. It's about how that data is structured and organized in a way that makes sense to AI.
Exactly. Right now, we rely a lot on huge data sets and machine learning algorithms to train AI. But there's a growing understanding that we need more clever approaches. We need to go beyond simply feeding AI information and find ways to help it really understand the concepts and relationships behind it. This is where techniques like knowledge graphs, symbolic reasoning, and even trying to copy the way humans learn come into play.
It's like we're trying to teach AI not just what to think, but how to think. We're trying to give it not just knowledge, but understanding.
Exactly. And that's one of the most exciting and challenging things in AI research. It's making us think really hard about what knowledge and intelligence really are and how we can recreate those things in machines.
This whole discussion about Expert AGI has been really eye-opening. It's clear that we're still in the early stages of this, and there's still a lot to figure out. But the possibilities are mind-blowing. Imagine what we could do if we can create AI that can really compete with human experts in terms of knowledge, understanding, and reasoning abilities.
The potential benefits are huge. We could have AI doctors who can diagnose diseases incredibly accurately, AI engineers who can design groundbreaking tech, AI artists who can create amazing art. The possibilities seem endless.
It's like having a team of super smart collaborators who can help us solve some of the world's biggest problems. But I have to admit, there's a part of me that's a little worried. What about the risks? I mean, we've all seen those sci-fi movies where the AI becomes self-aware and decides to take over the world.
I get those concerns, and it's super important to talk about them. Developing AI responsibly means not just focusing on the good stuff, but also making sure we're minimizing the risks. We need to make sure AI systems are aligned with human values, that they're transparent and explainable, and that we have ways to prevent bad things from happening.
It's like we're holding a super powerful new tool, and we need to figure out how to use it safely and responsibly.
Exactly, and that takes careful thinking, open discussion, and people from different areas working together.
So it's not just a tech challenge, it's a societal one too. We need to work together to shape the future of AI in a way that helps everyone.
Absolutely. It's a responsibility we all share.
Okay, so we've talked about the good and the bad, but what about right now? How might Expert AGI affect our lives in the near future?
Well, one area that's already changing is jobs. As AI gets smarter, it's able to do more and more tasks, which could lead to big changes in the types of jobs that are available. We need to be thinking about how to prepare for these changes and make sure everyone has a chance to succeed in this new world.
That's so important. It's not just about making cool new technology. It's about making sure that technology helps everyone.
Exactly. And it's not just about jobs. Expert AGI could change pretty much every part of our lives, from education to healthcare to transportation to entertainment. It's something that will shape the future in big ways.
It's both exciting and a little scary to think about. It's like we're just starting a new era, and we need to be ready for it.
Absolutely. And being ready means not just understanding the tech, but also really thinking about what it means and how we can shape how it develops in a way that matches our values and goals.
It's like we're writing the next chapter in human history, and we need to make sure it's a good one, full of hope, progress, and opportunity for all.
I couldn't agree more.
Okay, we've covered a lot today, from the technical stuff about the MMMU benchmark to the bigger picture of how Expert AGI could affect society. But before we finish up, I want to go back to the research paper for a second. We talked about those perceptual errors and lack of knowledge, But what about those reasoning errors that the AI has made? Those seemed especially interesting.
You're right. Reasoning is one of the key things that makes us human, so it's really interesting to see where AI is still struggling. The paper gave an example of a math problem where the AI got the right formula but then messed up the calculation. It's like having all the ingredients for a recipe, but then mixing them up in the wrong amounts.
So it's not just about knowing the rules, it's about knowing how to use them correctly in different situations.
Exactly. And that's a big challenge in developing AI. We can teach AI the rules of logic and math, but it's much harder to teach it the little details of how humans reason, the ability to make decisions, to consider different factors, to think ahead, to think outside the box. It's like that saying, knowledge is knowing a tomato is a fruit, wisdom is knowing not to put it in a fruit salad.
I love that. It perfectly explains the challenge we're facing. We can give AI all the knowledge in the world, but it's still us humans who need to provide the wisdom, the judgment, the creativity, the empathy.
It all boils down to understanding the difference between information, knowledge, and wisdom. We can give AI tons of information, even teach it to process and analyze it to get knowledge. But wisdom is something different. It's about understanding the real meaning of information, making good decisions, and using knowledge to benefit everyone.
It reminds us that even in a world that's more and more driven by AI, human intelligence is still incredibly important. We bring something to the table that AI, at least how it is now, can't copy.
Totally. And recognizing those special human strengths will be really important as we keep moving into this exciting and challenging new era of AI.
That's a great point. So we've covered a ton of ground today, from the nitty-gritty of the MMMU benchmark to the wider impacts Expert AGI could have on society. But I want to leave our listeners with one final thought. If AI is already having trouble with college-level stuff, what does that mean for the future of education? Do we need to change how we think about learning? What skills will be most important in a world with AI?
Yeah, it definitely makes you think we need to be talking about that stuff. The world's changing so fast. And our schools need to change too, to keep up. We can't just keep doing things the same old way and expect our kids to be ready for a future that's so different from anything we've ever seen.
It's like we're giving them a map of the world from 100 years ago and expecting them to find their way around in a totally new place. We need to give them the tools and skills they'll need to succeed in this new world with AI.
Right. And those tools and skills might be really different from what we've always thought was important in school.
So what are we talking about here? Do we all need to become computer programmers or AI experts to keep up?
Not really. Technical skills will be important, of course, but more and more people are realizing that we need to focus on developing those human skills that AI might not be able to copy. Things like creativity, critical thinking, problem solving, communication, collaboration, and being able to adapt.
Those are the skills that let us think outside the box, come up with new solutions, connect with others on a deeper level, and handle tough and always changing situations.
Exactly. Imagine a future where AI can do all the data analysis and complicated calculations, but we still need humans to understand those results, to make important decisions, to connect with customers and clients in a real way, and to come up with creative solutions to problems we didn't see coming.
It's a future where humans and AI work together, each using their strengths to do things they couldn't do on their own.
Right. And it's a future that requires us to rethink how we educate people. We need to move away from just filling students' heads with facts and instead focus on helping them develop those important human skills. It's not just about what you know anymore, it's about what you can do with what you know, how you can use your knowledge in new and creative ways, how you can adapt and learn as the world keeps changing.
It's about having a mindset of always wanting to learn.
Totally. And it's about realizing that education isn't just about getting a job, it's about preparing for life, for all the challenges and opportunities that are coming our way.
This has been a really interesting conversation. It's clear that Expert AGI could change our world in big ways, from the jobs we do to how we teach our kids. It's a future that's both full of potential and a little bit scary.
It's a future that we're all creating together whether we realize it or not, and it's a future that needs our attention, our careful thought, and our active involvement.
Well said. I can't just sit back and watch what happens. We need to be part of these conversations, ask hard questions, consider different viewpoints, and work together to make sure AI is developed and used in a way that benefits everyone. And on that note, I think it's time to wrap up this deep dive. But as always, we want to leave you with something to think about. Remember those skills we talked about: creativity, critical thinking, emotional intelligence, problem-solving, communication, collaboration, being able to adapt. How can we encourage those skills in ourselves and in future generations? How can we make sure that human intelligence keeps thriving in a world with AI? Those are questions we'll probably be thinking about for a long time. But that's what makes this whole journey so interesting, isn't it? The constant exploring, the search for knowledge and understanding, the challenge of creating a better future for ourselves and the people who come after us. So keep those brains working. Stay curious. And join us again next time for another deep dive into the most interesting and important topics of our time.